Hi friends, welcome back in the series of recommendation system. So today we'll be working on another case study that is on online joke recommendation system. So I hope the series of recommendation system is giving you the help is helping you in your daily life problem, or maybe in your daily life problem and in your learning journey, right? So let's get started before wasting time. So again, yeah, so we have today we have anonymous rating from the Jester online joke recommendation system. So what it is telling now, the abstraction is ratings are real values ranging from minus 10 to 10, right? The value 99 corresponds to null or not rated. So one row per user, that is the first column gives the number of jokes rated by the user. The next 100 columns give the rating for jokes 1 to 100, right? So we'll be using two data set in this. So there are link as well, but I'll provide the data set in the description for your convenience. Now the text of the joke can be downloaded here, right, and read the data set. So we'll be doing it further. So let's do our processing start. So let's start our processing. So first we importing pandas, we importing numpy, then we are importing the jokes.csv, that is pd.read csv. So this is the csv of jokes. So if we get the data.head, so here you can see that we have all this is rating, right? Now consider rating named data frame with only first 200 rows and all column from first of the data set. Now okay, we are having ratings, then as per this description, so ilog, so first 200, right, and all column from 1. So change the column indices from 0 to 99. So rating dot column equals to range rating dot shape 1. So in the data set the null rating are given as 99, so replace all the 99s with 0. So you can, yes, of course, use rating dot replace. So that is what we are also doing. So 99.0 will be replaced by 0. So if we get the new ratings data frame, so the value have been updated, you can cross validate them. Now you can just cross check them. Now normalize the rating using standard scaler and save them in rating difference variable. So from sklearn.preprocessing import standard scaler rating difference equals to standard scaler dot fit transform rating. Now rating difference that we have in this array. Now we are of course applying popularity based recommendation system. So find the mean for each column in rating different for each joke. So mean rating equals to rating difference dot mean xs equals to 0. Now we are considering all the mean rating and find the jokes with highest mean value and display the top 10 jokes id. So mean rating equals to pd dot data frame mean rating. Now mean rating dot ilog, right? So we are accessing these with doing some slicing. So here you can see that we have got top 10 jokes id, right? So here we have the context, that is for content based recommendation system. So the data set contains rating for 10,000 popular books. As to the source, so let's say that these ratings were found on the internet. Generally there are 100 reviews for each book, although some have less fewer rating go from 1 to 5. Both book IDs and user IDs are contiguous. So for book they are 1 to 10,000. For user they have similar this digit. All user have made at least 2 ratings. Median number of rating per user is 8. There are also bookmarked to read by the user, book metadata, author, all these things. Here is to recommend good books. So again we have the content for our books.csv. So now we have also imported that. If we check the head, so here you can see that how our book looks like. So book id, best book id, work id, right, books count, isbn number, all these required information. Now we are doing data pre-processing. So books sub, we are having the unique books with title, right? So first we are having a copy of book id and title, and then if we print the head, so the two attribute we have required, these are the two attribute that we required. Now scalar dot feature extraction, again text, we are importing count vectorizer, so initialize vectorizer. So vectorizer equals to count vectorizer, we are doing analyzer as word. Ngram range we are passing 1 to 2, stop words of course English, and minimum difference, that is the rare words, right? So here we are passing it as 0.002. Now vector dot fit book subtitle, book sub on title, so title matrix equals to vector dot transform, so book sub of title. Now title matrix dot shape, so this is the shape we have. Find vocabulary, so feature equals to vector dot get feature names, and then we are printing the feature. So here we got the vocabulary. Now if we print the length of this feature, so this is the length we have. So now what we are doing is confirm count of feature in the corpus. So word count equals to book sub of title. Now string dot content, so we are applying this regex kind of thing. So case equals to false of sum, and we are doing sum for this. Now for x in feature, so this will apply to all the x in the feature. So if we print the word count, so here you can see the word respected to the book title. Now find similarity between items. So of course first we'll import cosine similarity. So cosine similarity on title equals to cosine similarity, which will take two parameters. So we are passing title matrix as A and title matrix as again B. Now cosine similarity titles dot shape, so this is what the shape we have. Now getting the book to given title, so let's say title ID equals to 3. Now book sub of title dot ilog title ID, so to kill a mockingbird, right? Now np dot arg sort, so cosine similarity titles of 1. So this is what we got the array for this. Top and index, top and similar values, and top and similar value. If we print this, so this is what we got. Find top and with values greater than 0. So top and index equals to top and index of top and similar values, that is if greater than 0. Now book subtitle, right, of ilog, so we are applying this top and index on it. So we got a series of list name and of course the data type. Now consider the book to kill a mock bird, so location ID is 3 in our data set, so you can also check that. But what are the most similar books? So why does first to kill me if you can, and etc. So these are some similar book according to it, right? This is what the my team worked on it to get the similar, so that we can get a better example to explain it, right? So hope this is also helping you a lot. Now get book similar to a given title, so title ID equals to 1, right? Make this 3. Then book subtitle of ilog title, so Harry Potter and source serious stone, right? Harry Potter hashtag 1. So this is the book that we got on the title 1, right? Title ID 1. Now find out what feature have been considered by the vectorizer for a given title, right? So here we get to know that np.where np, we are using it title matrix of this, and to title matrix of 9247 to array, and if it is greater than 0, then feature if we call features 245, so we have it is war. Now to find but non-zero values, find out non-zero values from the count vectorizer matrix. So title ID, if we pass this, feature array we have, index we have, so this is what we will get the array of this. Now feature x for x in id x, so Harry Potter and Potter, so this is what we got these value from this array, right? So these are the title, and these are the IDs, and these are the title. Now let's wrap the above code in a function. So yes, of course we want to make a function where we will pass the title and we will pass the matrix vectorizer, of course, and then we'll get to know that the similarity of the recommender system, right? Now def return similar books, so here title ID, title matrix, and vectorizer top n equals to 10. Now first we are generating the similar matrix, okay? After that we are finding n with values that is greater than 0, and finally we are doing find features from the vectorizer matrix, right? So we are using the try catch blocks. If we get any exception, so that will be thrown that will be that will be covered by the exception. Now collate result. So of course in the areas we are having our result in the data frame where we'll have book title and title, similar books title, right? Scores we'll have. So let's see how we get the result. Now vector equals to count vectorizer, so analyzer word ngram range 1 to stop words English, and minimum difference as we are passing it. Now vector dot fit book subtitle, right? Title matrix equals to vector dot transform book subtitle, return similar books 1854, title matrix vector top n equals to 20. Now guys, this is the last part that we have, and which is the core of this topic, no, like how our result look like. So actually, so as I said, these are pre-trained models. So but yeah, if you type the code into your machine, you will definitely get the exact answer if you run with our provided CSP, or if you have any other data set according to your specific problem, you can work with that. Okay, now we have, you can see that what we are calling the return similar books, right? We are passing the title matrix that we have here, this one, and the vectorizer that we have of title and top and 20. So we need 20 similar books. So we have passed the ID as 1854, right? But according to that, what we got, the 7 spiritual laws. So you can see that the name, right? So we have the so 1854 contains the 7 spiritual law of success, right? But according to that, we got similar books like the seven spiritual law of success, a practice, the 7 habit of highly effective teens, the hollows, of course, Hogwarts, right? The success principle, Einstein's dream, the happiness advantage, right? Inna May's guide to children, waking up, preach my gospel, Succub's dreams, so on so forth. We got the 20 similar images. And what word were similar, like here we have dream, guide, 7, success. So here it matched with guide and success. Here we have 7, here we have guide, success, dream, happiness, 7, success word, right? And this is what you can see the score as well. If all the 100% matches, then we will get 1. So in 1 we have only 1. Then if we check the 3, so 1 2 3 4, so it has given us 50% of score, right? So this way you can easily solve your problem, and you can easily get to know that how we can apply this content based recommendation system. So yeah guys, I hope this video helped you a lot. If yes, please do like, share and subscribe. That will motivates us a lot to work more on this kind of case studies, and our team is only then will be highly motivated to get the content, right? Because if we get support from your side, then definitely they will get more motivated, and they will try to do the best for you. So yeah, this was all about this video. Again, thanks a lot for being with us, and let's meet in the next video. Till then, all the best, take care, have a good time.